This is Quadratic Inequalities, Unit 4, Section 6. So, the first part is solving single variable quadratic inequalities using graphs. So the example just says solve the inequality. Okay, so let's just look at the graph and the equation. Notice on the equation, as soon as this works for me, on the equation we have greater than, not greater than or equal to, not less than, and so on. So we have greater than. Okay, so what that means is I want to be greater than 0. Well, again, you don't have to write this part down, but just to illustrate, since we're talking about x and we want to be greater than 0, the value of 0 is the x-axis, this green line right here. So that is where x equals 0. So I want to be greater than that or above that, right? So if I want to be above that, if I look at my graph, notice that I'm above 0 starting at -2 going this direction, and from +2 going this direction. So notice my lines, that from +2 it's going to go up, right? It's going to keep going up no matter how far right that I go. And likewise on the other side, my graph is the line's going to keep going up forever as far as I go left from those 2 points. So I'm going to be greater than 0 from anything from -infinity up until -2, and then I stop being greater than 0 because notice that's when it goes down, right? So I'm below 0, and then I go above 0 again, starting at 2 all the way to forever, which is infinity. I know that infinity sign's terrible over there. So that's how we got to split this up. So notice my graph is, most of it is above 0, but that one little part right here in the center, this one little part is below 0. So I have to cut that out of my answer. Now how do I do that? This is where you have to pay attention to writing it correctly, or on the quiz or test, choosing the right format. So if you ever have a split, that means I'm going to have an or. I'm going to have this section or this section. Okay? So now again, this is the formal way to write this. So I'm going to have my little fancy bracket, and I have x such that, I know we haven't done this in a long time, x such that, and then I write my two areas that are above 0. So my first one is when x is less than -2 or x is greater than +2. Then fancy bracket, and that's my answer. So notice I write my left side, my left range first. I have my or in the middle, then I have my right range on the right. So it should go left or right. That's kind of what it is. So I have left or right. Now that's only if it's split. Okay, so if it's split, I have to write it like this. There are other ways that you can do different forms, but this is the form that's best for this one, easiest probably in my opinion. So yeah, so I just do left or right. So my left is less than -2, my right is greater than +2, and notice these signs have to match the one that I have originally in the problem, as far as not going in the same direction, but underlined or not underlined. They all have to be the same. So if the question is not underlined, the answer is not underlined. If the question is, then it is, and so on. Okay, so that's number 1. Now that's if your answer is split. So let's look at one that's not split. Look at number 2. Number 2, now I'm greater than or equal to 0. So if I look at this again, I'm talking about x greater than 0. So my x being 0 is this line again. And I want to be greater than that. So if I want to be greater than 0, notice it starts at -1 and it goes all the way to positive 4. All of that area in between negative 1 and 4, all of this is above 0, right? So that means I don't want the left or right, I want the middle. So on these answers, on 1 and 2, in this type of question, you're only going to have a left or right as one answer, and the only other option is have a middle. So you're going to be split or together. In this case, it's together. So these answers we write a little bit different. So notice I start at negative 1, I end at positive 4. So let's start with that. I'm going to go from negative 1 to 4. Now I can't just have it like that because that could be confusing. I'm not really sure what it's supposed to be. So you're going to use brackets or parentheses. So if you remember, if I'm less than, equal to, greater than or equal to, I'm going to use brackets. If I am just less than or greater than, I'm going to use parentheses. So in this case, since we are greater than or equal to, we are underlined. We're going to put the brackets like that around the numbers, and that would be my answer right there. So notice, because my graph, my range is together, right, it's in the middle, my numbers are together. There's no or, there's no split. Whereas on the first one, because my ranges are split on the left and right side, and I don't want the middle, that's where I have to split it with this or in the middle. So those are the two ways you can write those, either together or apart. Those are the only two options, luckily, so there's only two ways to write the answers. Alright, moving on to B. So on B, we want to solve single variable quadratic inequalities using algebra. So now we don't have the graph to help us. I mean, you certainly could graph these if you know how, or using a calculator that might help you out. The only problem being that finding the numbers you need may be difficult, and that's just how the questions are designed. So I just want to solve the inequality. So I'm doing the same thing as before. I should get, again, only one of two ways to write my answer. I'm either going to have the left or right, or my other answer could be just the ones that are together with the brackets or parentheses. So those are my only two options. Again, that doesn't change. What changes is how I find the answer. So on these, you need to solve for x. That's the first thing you have to do. Now you can solve using factoring, square root method if you like that. Quadratic formula works for all of these. Whichever way you prefer, you can use. Now I will say, I wrote these on purpose to be able to factor. So for most, I think all of the homework and practice, you should be able to do factoring or the quadratic formula. They both work for every question. So whichever one you're comfortable with, just use that. So I'm going to go ahead and start on this one with factoring. So when we factor, I'm going to do the first times the last. So 4 times negative 2 is negative 8. Okay, when I factor, I know I'm going to have two parentheses. I always do. And because my first x squared, or my x squared is 4x, both of these start with 4x. So I set up my answer right away, or at least part of what I'm going to. And now I want two numbers that multiply to negative 8 and add to negative 7. So the thing I can think of right away would be minus 8 plus 1, because negative 8 times 1 is negative 8. Negative 8 plus 1 is negative 7. So I've done that. And now I just want to solve for x. So when we factor, you know, you have to reduce the parentheses, all that stuff. So when I'm just solving for x, I don't have to worry about that because that'll kind of work itself out as we solve these. So to solve for x from here, I'm going to go ahead and split this down the middle, and I set each one equal to 0 like we did before, and solve for x. Now, if you're familiar with the shortcut, you by all means do that. So I add 8 on both sides, So I have 4x equals 8 divided by 4. X equals 2 on the left side. Then subtract 1 on both sides. Divided by 4. And x equals negative 1/4. So when I solve for x on these problems, these are what's called critical points. So the critical points are the points in the graph where the graph goes from positive to negative or negative to positive. So just real quick, on the graph up here, the points that we have circled, that's the point where right before is positive or right before is negative, and that's the point they switch. So they go from one to the other. They go from the top to the bottom or bottom to the top, depending on how you want to look at it. So in here it's the same thing. I just don't have a graph to look at. So I solve my x. Those are my critical points. Now, my critical points are important. They are part of my answer. However, at this point, I am not sure exactly if my graph is going to, or my answer is going to be the left or right, or if my answer is going to be the ones that together, just the two numbers with the brackets or parentheses. So, in order to make sure, I mean, there are ways you can do without. There's other things you can do if you think about it, but just to make sure that you have the right answer, I'm going to go ahead and write a number line like this. And anywhere on here is fine. I'm going to write my two critical points. So I have negative 1/4 and positive 2. Okay, I can't use those points. They won't help me because those are on the zeros. So I need to know when my graph is below 0 or less than, right? So because I want less than, I can't use those. I got to find something else. So here's what I'm going to do. I'm going to pick any numbers that are outside of these numbers. So like, for example, I want a number below negative 1/4. I want a number in between those two, and I want a number above 2. Now, realistically, you only need 2 numbers. But I'm going to go ahead and write 3, and then we can pick 2 to work with. It's okay. So you only need 2 of them. You only need one on the outside and one in the middle, because that's my answer. It's going to be the 2 outside numbers or the middle, and that's it. So obviously the easiest one in the middle, between negative 1/4 and 2, easiest one always, if you can use it, I would, is 0. 0 is by far the easiest number to plug into anything. From there, I would go as small of a number as possible, because again, you don't need to go really large. That's pointless. You'll get the same answer either way. So less than negative 1/4 is just negative 1. Greater than 2 would be 3. So those are my 3 numbers. Now you just have to figure out which 2 you want to try. And really, if you try the first one and it works, great, you're done. If you try the first one and it doesn't work, then really it's the other 2. So let's put that to the test. I'm going to go ahead and try the easiest one possible, which is obviously 0. So I'm going to plug this number in to my equation from the question, right? So I have 4 times x squared, which is 0 squared, minus 7 times 0 again, minus 2, and it should be less than or equal to 0. If that's true, that is my answer, and I can go ahead and write, well, that's my range, let's put it that way, and I can write my answer. So let's figure this out. I have 0 squared, well, everything times 0 is just 0, and then that's also 0, and then that's minus 2. Of course, 0 minus 2 is negative 2. Now you got to ask yourself, is negative 2 less than or equal to 0? Why, yes it is. Therefore, this is my range that I want right here. I don't want these 2. So my answer is going to look like number 2, where I have just the 2 numbers with the brackets or parentheses. Okay. So when I write my answer, again, I just write my 2 points. So I have negative 1/4 and 2. And I look at my symbol. My symbol right here is underlined. So because it's underlined, I use the brackets, not the parentheses. and that would be my final answer. Now, of course, when you're doing this, if you had plugged in 3 or -1, you would have found that it is not less than 0, and so you could have marked those out and you would have already known that the middle is your answer. Okay. Now, if that seemed like a lot, I apologize. Let's see if maybe number 4 helps understand a little better. So I'm going to do the same thing. You got to solve for x. You can factor. You can do square root. You can do quadratic formula, whatever you want. I'm going to factor again. So I do first times last. So -2 times -15 is +30. Okay, I know I'm going to have 2 parentheses because I always do. And because my x squared is -2x, that's what I'm going to write in both of these. And I want two numbers that multiply to 30 and add to -11. Of course, those numbers would be -6 and -5. Alright. Now, here's the only thing that is a little tricky on this one, only because I have a negative in the front. When you have a negative in the front, only one of these parentheses can have a negative number. So, I know I just made it a little more difficult, and that's okay. So in this case, if you ever have a negative, it might be okay to go ahead and divide out a common number. So notice on the left side, the -2x minus 6, I can divide by -2 on both. On the right side, I can't reduce 2 and 5. So I'm just going to leave the right side, I'll change the left, and then I'll solve for x from there. So when I do this, I end up with positive x plus 3. And on this side, I have -2x minus 5. Okay? So now I can solve for x. So again, I set these equal to 0. Okay? And then solve for x. So -3 on both sides, x equals -3, and add 5 on both sides, divide by -2. So again, I get another fraction, but that's okay. So those are my critical points. Those are the points where the graph goes, positive or negative, and switches. So, again, you can go through and plug in the numbers, or you can avoid doing that if you just think about what the graph would look like for these questions. So, on number 3, I showed you kind of the long way. I wanted to show you that on purpose because there always is a way to check your answer to make sure it's correct by plugging in the numbers. But if you know what the graphs look like for quadratics, then you don't need to do that. So, for example, on the notes down here, let's say I have y equals positive x squared and then so on, right? As long as my first number is positive, my graph is going to go up. And hopefully you remember that. If I have y equals and then -x squared dot dot dot, like, doesn't matter about the rest of it, then my graph is going to go down. Okay? So think of it this way. If I want above 0, greater than 0, I can think of how my graphs look and easily know where my graph is above 0. The same with below 0. So let me look at number 4. Notice number 4, I have a -2x squared. So if I have -2x squared, my graph should look like this. And again, I'm not specific on where it is placement-wise. I don't need that. I already have my critical points. I just need to know, is my middle part above 0 or my left and right above 0? So looking at the graph, the picture, I can easily tell that if these are my critical points and I want less than 0. So if these are my critical points and I want less than 0, it is below 0 going left and going right. So that means I don't want this middle area at all. So I have a split answer. Remember, the split answer looks something like this. So I have x such that x on the left, remember this is the left, and then this is the right. Okay, so I've kind of skipped the plugging in part because the graph to me is a little easier. This is how I would do it in my head. I just show the numbers, the plugging in, because it helps to understand why this works. You know, why you can do the graph versus plugging in the numbers, as long as you understand that how they both work. So I'm gonna go ahead and write the answer. So I have my I don't know what that was. Fancy bracket, x such that x. Now I'm going to match. I'm going less than 0. Okay, I don't know what that was. My phone. All right. So I want less than 0, and so I start with my left point, which is -3. -3 is less than -5/2. So that means I am less than -3, because that's -3 right here, and I'd be going left forever, right? Or x is greater than my other critical point right here, because greater than, I'd be going to the right, which is above as far as going, you know, left to right, and that would be the -5/2. Of course, the picture's not accurate, but that doesn't matter. I have the numbers that I need. And that would be my answer for this one. So I have left or right. And I guess if you want to think about it, on the left side you'll always be less than or underlined. On the right side you'll always be greater than or underlined. Because I'm going left and right. And so left is less than, right is greater than. And so that'll always be there. It's just the numbers you have to find, which are my critical points that we did find. So using the graph way works. If you don't like that, that's fine. If you don't understand it, it's okay. You can always plug in numbers. But if you feel like numbers are just, this is too much, and you understand the graphs, then great. And notice if I look at this one, my A is positive, and so on my graph, I'll write it down here, it would look like this. And so yeah, my middle section right here would be less than 0, and that was true. We did find out that indeed between -1/4 and 2 is less than 0. So again, I could have skipped the plugging in the numbers, or you can do it on all of them. It's fine. Either one works as long as you understand the graphs. But if you don't, just plug in numbers and you'll still get the right answer. Alright, so let's move on to the next part. Solving two-variable quadratic inequalities. So here where it says solve the inequality, I guess it should say graph, but solve, same thing. Because the graph would be the accurate representation of this anyways. So to graph this, the first thing we would need, or I guess the most important thing for any quadratic equation, is the vertex. So I know this is going back a ways, but if you remember, we have A, B, and C. And so the first thing we have to do is find the vertex. To find the vertex, we have to find x and y for the vertex. So that takes us to x equals -b over 2a. So we've done this before, it's just been a while. So -b, or I just take b and flip the sign. So since b is -3, -3 is 3, and then 2 times a is 2. That gives me 3 over 4. So I know x is 3/4. Now to find y for the vertex, I plug that in and solve for y. So I'm using my equation here. So I'm going to have 2 times 3/4 squared minus 3 times 3/4 minus 2. And I know this one has a fraction. Again, I try to avoid fractions as much as possible. Sometimes it's very difficult to do so, but we're doing them in here in the notes, so that way at least you see how to do it. And again, it just takes practice. So on this first one, I have 2 times 3/4 squared. I just square the top and the bottom. So I have 3 squared is 9, 4 squared is 16. Okay. 3 times 3 is 9, divided by 4, I can't change. And then of course I still have minus 2. Alright. Now eventually I got to get all these to be fractions over the same number. So let's go ahead and reduce this one right here, the first one. 2 and 16 can reduce to 1 and 8. So in this first number I now have 9 over 8. So 8 is my denominator that I have to get to be the rest of them. So like on this one, to make 4 8, I would multiply by 2. So I multiply 9 by 2 and I get 18 over 8. Okay, 2 times 4 is 8, so that would just give me, oh no, not that, I'm sorry. I forgot, denominator is 1. So 1 I would multiply by 8, so 2 times 8 is 16 over 8. Now I can subtract all these because now they're all over 8. So 9 minus 18 is negative 9 over 8 minus 16, which then gives me a negative 25 over 8. So that's my y value. So my vertex is, we found 3/4 and negative 25 over 8. So the first thing I want to do is graph my vertex. So I go 3/4, so about right here, and negative 25 over 8. Well, 8 goes into 25 3 times, so a little over 3. So about right here. Again, I'm not looking to be exact, but I want to be fairly close. So 3/4 is less than 1. 25 over 8 is just over negative 3. Alright, now from here, I got my vertex. Now we have to go back and use the quadratic pattern. Remember, the quadratic pattern from the vertex is over 1 up, well, let me put it this way, 1 times a, or a times, however you want to put it, 1 times a, and then over 2, and then up, 4 times a. And that would be the same, it'd be repeated on both sides. So eventually, you know, if you go this way and go up, I do the same. So I would get a graph like that. I know it's a terrible U, but that's pretty much what you're looking for. Alright, so on my graph, my A is 2. So from here, I'm going to go over 1. And instead of up 1, I go 1 times 2, 1 times a. So I go up 1, 2. So about right there. Same thing on the left. So I go over 1, up, about the same. And then I do the 2. So I go over 2, and I go up 4 times a. 4 times 2 is 8. 1, 2, 3, 4, 5, 6, 7, 8. Way up here. And then of course it's the same thing on the other side. Again, relative, give or take a few. As long as you're pretty close, it's okay. And now I draw my line. I have to make sure, though, my line matches my sign. So if my sign is not underlined, I have a dotted line. If my sign is underlined, I have a solid line. And that goes way back, beginning of the year kind of stuff. So because my y is less than, it's not underlined, I have a dotted line. So I'm going to have a dotted line through here. And then you have to shade. That's the last part. So once you get the vertex, that's really most of the work. From there, you use the pattern to get a few more points. You drew a dotted or solid line, and then I'm going to shade either above or below. In this case, because I'm less than, I'm going to shade below. So everything below the line would be all down here, and that'd be my answer. Now, of course, on a quiz or a test, this is obviously going to be multiple choice. So as long as you can find the correct vertex, get the right line, and shade in the right area, you should be good on these questions. Okay? It's just no way I can have you practice choosing, so it's better just to practice drawing it out on your own for homework. Alright, 6, I'm going to do the same thing. So I have first A, B, and C. So I'm going to start with x equals negative b over 2a, which gives me 7 over 2 times negative 2, which is 7 over negative 4. Okay, that's my x value. Now I plug that in and find y. So I have negative 2 times negative 7 over 4 squared minus 7 over, or times 7 over negative 4, and then minus 3. So again, fractions, again, I apologize, but fractions are really hard to avoid sometimes. I do my best, I promise. Okay, so the first thing, we have negative 2 times, since it's a negative squared, we don't have a negative anymore, so I would just have 7 squared is 49, 4 squared is 16. Okay, 2 negatives make it plus. 7 times 7 is 49 over 4, and then minus 3. Okay, now again, I can reduce. I have negative 2 and 16 gives me negative 1 and 8, so that's just a negative 49 over 8. Okay, so I'm going to do the same thing that I ended up with before. I want this to be 8, so 4 times 2. So I do 49 times 2 is 98 over 8. And then 3 over 1, so I want 1 to be 8. So 3 times 8 is 24. Now I can just subtract, add, whatever all these are. So negative 49, plus 98 is 49 over 8. Minus 24, that was a text message, by the way. And then I subtract those, you get 25 over 8. So I can now graph. Yay. The hard part is over. And again, with practice, again, I make it seem easy. I have practiced quite a bit. So if you aren't practicing enough, you only do the 2 with me, you may not be very proficient. So I would definitely practice these. So my x value is negative 7 over 4. Well, 4 goes into 7 not quite 2 times, so I'll be probably right here. And then 25 over 8, 8 goes into 25 just over 3, so I'm up here somewhere. And I'm going to use my quadratic pattern. Notice my a is negative 2, so I'm going to go down, but it's still the same 2 that I just had. So I go over 1, I go down 1 times 2, so 2. Same on both sides. Then I go over 2, and I go down 4 times 2, which is 8. So 1, 2, 3, 4, 5, 6, 7, way down here. And the same thing on the other side. So let me get rid of all these extra dots that we don't need. Okay, so I have a greater than or equal to, so a solid line on this one. So I'm just going to connect all my dots. This is very easy compared to the dotted line. And because I am greater than, I'm going to shade above the line, just like that. And that would be my answer. So again, on the quiz and test though, you're just picking the right graph. So you have to make sure you can find the vertex, know if it's dotted or solid line, and know if you're shading above or below. So most of the work, as far as the quiz and test will go, will be finding the right vertex. After that, it's fairly simple as far as a line and the shading. So that is 5 and 6. Alright, last 2. Oh my goodness. I'm just going to ignore that. Alright. So last 2. Solving systems of 2 variable quadratic inequalities. So notice we have 2 quadratics to solve. Now these are kind of the same as what we did. We have to find the vertex for each one, use the pattern, the quadratic pattern to graph both. Only this time, you always shade in between. Well, I say always. For this class, for my homeworks and everything that I do, it's always in between. Of course, that is not always true in reality. If you get into higher level math, that won't be true necessarily. But for me, it's always in between. So I do make it a little easier on that because I'm trying to, this is more of an introduction, not really the advanced stuff. So I have A, B, and C, and that's for both of these, right? So A, B, and C. So all I have to do, again, find the vertex for both, graph both, and wherever they intersect in between them is where I graph. So that's what I'm going to do. So I'm going to start with the first one. So x equals negative b over 2a. So I have positive 2 over 2 times 1. Because remember, if there's no number, it's a 1. That gives me 2 over 2, which is 1. A nice low number, the whole number. Great. So I plug that into my equation and find my vertex, my y value. So I have x squared, which is 1 squared, minus 2 times 1, minus 3. 1 squared is 1, minus 2, minus 3. 1 minus 2 is negative 1. Minus 3 is negative 4. Sweet. So I got that one. I'm going to go ahead and keep going. I'm on a roll. So now I do the second one. So I do the same thing. X equals negative b over 2a. So x equals negative 2 over 2 times negative 1. That gives me negative 2 over negative 2, or positive 1. So I got a 1 again. Very simple. I plug it in. 1's negative, 1 squared, plus 2 times 1 plus 1. That's negative 1 plus 2 plus 1. 1 plus 1 is 2. Awesome. So let's go ahead and plot these. So on the first one, I have 1, negative 4. So I go over 1, negative 4. There's my vertex. And now I use my quadratic pattern. Since my a is 1, I just go over 1, up 1, over 2, up 4. Same thing on the other side. And because my sign is underlined, this will be a solid line, right? So I have a solid line going this way. So there's the top one. And the bottom one, I again do the same thing. Plot my vertex, use my quadratic pattern, graph the other points, draw the line, then I can shade. So I have 1 and 2. So I go over 1, up 2. Now notice this a is negative 1, so I'm just going down, but the same thing. So I go over 1, down 1, over 2, down 4, and the same thing on the other side. And this symbol, this sign is also underlined, so this is also solid. I don't know why there's a little dip in mine, but that's okay. It's not going to be perfect because this is not art class. Sweet. So notice where they cross. I have the blue one facing up, the purple one facing down, and the in-between. Again, like I said, for my questions in this class, the answers for these will always be just shaded in between. That's what I'm looking for. And so on the quiz, on the test, again, as long as you can get the right vertices, both vertex, and know if it's a solid or dotted line, then you'll be good to go. Because on the quizzes and the tests for these, it's always shaded in the middle, so you have to focus on the vertex for each one. That'll be the main focus. So again, 7 and 8 are very similar to 5 and 6. You just have to do 2 instead of 1. So this one, same thing. I start off x equals negative b over 2a, which gives me, oh, I didn't even label. Sorry, let's label first. So I have a, b, and c. And notice if I don't have a c, it's 0, because that's the same thing as plus 0. Then I have a, b, and c down here. Alright, so now, I'm sorry, we can go back now. So negative b is negative 2 over 2 times 1/2. You might be thinking, oh, fraction, why? Oh, don't worry, watch. Negative 2 over. Half of 2 is 1. Look at that, no more fraction. That went away pretty quick. Now I got to plug this in. So I have 1/2 negative 2 squared plus 2 times negative 2. Now you might be thinking, oh, see, look, there's a fraction again. You told us. I know I told you. But watch. Negative 2 squared is positive 4. 2 times negative 2 is negative 4. Now what's half of 4? 2. Oh, look at that. The fraction went away. Now, before I move on, I guess maybe this will be easier. Let's graph 2 and or negative 2, negative 2. So do negative 2, negative 2. Now this one, my a is 1/2. So when I go over 1, I go up 1 times 1/2. So I go over 1, up half. I go over 2, up 4 times half, which is just 2. So this one will be a very gradually opening or wider graph than before. Okay, so there's my top one. Now I got to do the bottom. See how these can kind of be fairly quick if you know what you're doing and you're well enough with numbers that you aren't having to get out a calculator to add and subtract basic integers. That's okay. If you have to, I understand. But the more you practice, the easier it gets, and the less you rely on looking back at notes every time or having to type everything in a calculator. Sometimes it's just a little quicker to do as much as you can without anything. Because I'm not using a calculator for any of this stuff. This is how I also keep my skills up. So I do the same thing. Alright, so negative b over 2a for the second one is positive 4 over 2 times a is negative 2. So 4 over negative 4 just gives us negative 1. Now we can plug that in. So negative 1 squared minus 4 times negative 1 plus 2. So I have negative 2 times negative 1 squared is positive 1. Negative 4 times negative 1 is just plus 4 plus 2. Negative 2 times 1 is negative 2 plus 4 plus 2. Negative 2 plus 4 is 2 plus 2 is just 4. So for my next graph, my second one, I have negative 1, positive 4. So way up here. My a on this one is, oh, I just noticed something I did wrong, but I'll fix it in a minute. It is negative 2. So because my a is negative 2 and I go down, I'm going to go over 1, down 1 times negative 2, which is 2. Same thing on the other side. I go 2 and then down 4 times 2 is negative 8. So that's way down here. Same thing on the other side. Okay, so here's what I messed up. And some of y'all are probably like screaming at me through the video. Fix it. You did it wrong. You messed up. Hey, I know, I can't hear you. That's fine. I caught it, luckily. If you already caught it and fixed it, great. If not, here's what I did. Or I guess did not pay attention to. My signs on this one are not underlined. Therefore, my graphs will be dotted lines. Oh, whoa. Not solid lines. So, that's very important. So see, even sometimes I don't think about it sometimes. And luckily I noticed it before it was too late. So when y'all are working these out on your own, it's okay if you make a mistake. The good thing is if you can catch it in time, especially on a quiz or a test, you want to catch your mistakes in time before you submit the question. I mean, it happens. I don't know what else to say. Mistakes happen. Everybody makes them. I just did one, but I caught it. Because again, because I do this so much, I don't necessarily think of everything all the time. But moving on real quick, last thing I forgot too, we had to finish. Got a shade in between, and we're done. So that's how you do those two, and that is it for this chapter. So that means the test is coming up soon, make sure you are prepared.